Assalamualaikum warahmatullahi wabarakatuh. My name is Gina Fadla Kamilah, and I'm from English Literature Department in 5th semester. And today, in this occasion, I want to perform simultaneous interpreting for my assignment, and the interpreting about energy and decarbonisation by Lida Ruishalme.
Okay, so we now come to the afternoon session. It's about green skepticism. And just to give the overall context of the session, which is in two parts, let's go back 6 years to Stockholm, when we had Hans Rosling talking about misconceptions of the world, and he showed at the time that the world is a lot better than most people think. But obviously, the plus in so many things has also come at a cost. We've been able to improve life expectancy, reduce absolute poverty, and many other things like that. But it hasn't come at a zero cost. As in medicine, we have no effect without side effects. And the effects, by the way, might be fading too. If you look at the absolute poverty, for example, where Hans Rosling thought that we are well on track to eradicate absolute poverty by 2030. The last couple of years have seen a backwards direction with, instead of just 800 million, it's gone up to 900 million. So it's also in achieving things that we need to put a lot of effort. And it's very difficult to convey to the public what is the difference between the effect, what are the plus and the advantages that we have, and what are the disadvantages that we need to compensate for as well as we can. And it's also not correct that we as skeptics or scientists tell politics what they have to do. They have to make decisions, and it was mentioned in the first session that we need to also make sure that we provide rational, good information, and then leave it up to the politicians then to make their decisions based on that. And in general, not to say that there's no alternative as to what the scientists say, which usually is not the case. It's our job to inform about what is reliable knowledge, what are facts, and what are not. And much of what the Green Movement, by the way, asks for is things that I think we can all share as skeptics. We want an intact and livable environment, but are we on the right track? Are we being hindered by unfounded popular beliefs? And that's going to be part of this session. Two areas where such popular beliefs and facts affect political decisions are on energy and climate, and also on agriculture. And so we will have today two sessions. Actually, two sub-sessions. We'll have first with Ida and Mathis talking about energy and nuclear power. And we'll come to the second session after that, then we'll have a break. There'll be no questions at the beginning after each of the talks. We'll have a break after that, then we'll have the talk on agriculture and GMOs. And we'll have a panel discussion where you will have ample time to ask questions to all the speakers. And so to begin now, let me call Ida to give her talk. She's quite well known in the Mothers for Nuclear, has been involved in a lot of eco-modernist groups, including the German and the Finnish eco-modernist groups. And she's going to talk about energy and decarbonization, and so I hand over to Ida.
Should I keep the laptop? No. So I would like to say thanks so much to Amadeo and for the Skeptics Congress for inviting me to speak here today. And I'm here today talking about the more specific title of my talk is critical thinking, because we want to be taking green energy goals seriously. So first I'd like to just say a few words about myself. Amadeo told you that I'm an
Saya ingin mengatakan
ecomodernist.
beberapa pepatah
I'm
tentang
also
diri saya.
I'm a
Seorang
biologist.
Bardeo mengatakan kepada
I'm
saya
a mother.
bahwa saya
I'm an
adalah seorang ahli
environmentalist.
biologi, saya adalah seorang
And
ibu,
I'm many other things, just like we
saya adalah
all are.
pecinta lingkungan dan
I'm
banyak
an
hal
avid
lain seperti
hiker
kita
and
semua.
I'm nature lover and I love
Saya
sci-fi and
pecinta
Star Trek
alam
and
dan saya
sausage
cinta
dogs.
sci-fi
Yes.
dan Star Trek.
So, and the reason why it's also important to have an idea about who is speaking here today is that often when we talk about these topics, both on
Tentang
healthcare
topik ini
as
baik
well
tentang
as
perawatan
environmental topics,
kesehatan maupun
is that
topik
people
lingkungan
often
adalah
they are
bahwa
not as
orang
interested
sering
in listening if they
mereka
don't know
tidak
why
tertarik
we're talking
untuk
about them.
mendengarkan
They don't know
jika mereka
what
tidak tahu
motivates us
mengapa kita
and what
berbicara
kind of
tentang
values
mereka.
we share. Because as we spoke to earlier, there's this question about skepticism and policy, that we should not tell politics what they should do, we should inform them about the effects of their choices. And it should be very clearly communicated that when we talk about green skepticism, we talk about the value in green things, which is basically protecting the environment, maintaining diverse ecosystems around the world, that we assume this is our premise, that those things are something that we should protect. So actually this is sort of more unsaid in when we talk about healthcare and alternative medicine more often, because there is also the value that we want to protect human health. But it's not as often, we don't actually feel the need to differentiate that. But this is a core part of why we want to look at green topics in a skeptical way, because they are so important, because it is vital to get environmental questions right. So many people think that often skepticism, as it was mentioned earlier, that we can be perceived as nerds and weirdos, but also that we can come across as we are only there to pick apart well-meaning ideas or point out to people when they're wrong. And as Professor Ernst very well said, we need to frame the discussion differently, that we can't only be against quackery or sham treatments. We have to be for progressive healthcare. And this is a value. We are for environmental policies in energy and agriculture. So I think both topics are important, but I'm here today to talk about energy. And particularly then, when we talk about these issues, we will come to the uncomfortable situation that sometimes we have to do the skeptical thing and point out where these ideas are not really well founded in evidence. Because oftentimes we make quick gut-based decisions, and we have these intuitive perceptions about what is good for the environment and what is natural and what can help us reach these goals. But they're not always correct. It's not an error-free process. We have this inborn way of judging what is good and bad, and what things are risky and what are not, that have developed during a long evolution, that have been very useful for us, but in our environment that is filled with abstract information and complex problems, it can lead us astray. So we have this process of easily, if you look at risk research and listen to risk researchers on how we make these judgments of what's good and bad for health, for environment, what is risky, they will tell you that people always tend to have this overarching theme of inflating the feel of risk when it's something that's unfamiliar, when it's something that's outside of our control, when it's something that's artificial. So we easily find anything that ticks those boxes risky, whereas we underestimate risks that feel familiar, that we can control ourselves. So these kind of influences affect all of us. We can try to be more aware of them, but they live on in our culture, they become reinforced by what other people and what culture tells us. So this is how we end up with lots of ideas where we might have to come to the uncomfortable situation that we, by assessing them, we notice that they are not all correct. So when we talk about energy, this is most striking then with our most new and strange and unfamiliar form of energy, which is nuclear power. We have a more intuitive feeling to the familiar forces of energy that we use. We can sense them with our senses. We know that wind can be harnessed with sails, that flow of water, you can feel it, you can change it. We know we can feel solar effect of warming. We can avoid these risks as well by going to the shade. We know that by burning stuff, we get energy, and we also get the drawbacks of, say, smoke. But we know how that is dealt with. You go away from the smoke, you avoid it. It's not scary to us. We do know rationally that it causes risk, that it has an effect on our health, but it's not an alarm bell that goes off in our heads. Really, that is something you should avoid and go the other way. But this happens a lot with nuclear power. Because we don't have senses for it, because we can't control it. They're only very trained nuclear engineers who have the practical know-how, how do you control a nuclear reaction. So it will always have this position of being a target of inordinate fear. So if you listen to risk researchers, I will quote Peter Sandman, for instance, saying, the risks that upset us and the risks that kill us are two completely different things. Because as you see here, so in this graph, you have here amount of fatalities, human fatalities per unit of energy produced. And this is, these statistics is not a controversial question. Actually, you find them in published literature, you find them on statistics sources like Statista, in EU projects where they take into account energy externalities. So we fear nuclear power most of all, whereas coal causes an inordinate amount of the actual deaths. We know that coal is bad, but we're not exactly afraid of it. We just want to get rid of it because it's unpopular. It's not that it causes us anxiety, for the most part, unless we talk about climate anxiety then. But this is the kind of situation we're in. So I want to talk about what kind of requirements we should pose for green energy, what kind of things we need from energy in order to reach environmental goals. But often this discussion is hampered by the fact that this kind of risk perception, skewed risk perception, to start with, stops us from having a level-headed discussion, trying to look at the actual evidence and comparing things, because we have a very inflated sense of risk in nuclear power. So let's look at a few of the most common points where risk perception and actual knowledge are very far apart. So the most common must be that nuclear power has risks that are beyond consideration because of the long-lived, incredibly dangerous nuclear waste. This used to be my reason for being against nuclear power, actually. I thought that having this hanging risk on the necks of generations to come was just such a heavy reason that we should reject nuclear power, period. There was no justification for producing any amount of energy since it was so incredibly dangerous for generations to come. But then, as I stopped to reflect these ideas and I spelled them out loud for myself, it was really quite striking, because the thinking was this: I just know that nuclear waste is bad, really bad. I don't actually need to go and check the data. How bad, to what degree, how. I just know already. It's logical to reject it because of this knowledge. But I'm sure you know, and I know from personal experience, that just knowing is a really risky position to take if we want to understand something properly. So let's look a little bit about what we actually know about nuclear waste. So in this chart, you have radioactivity measured in relative activity. It's your typical kind of waste from a light water reactor, a very common type of reactor, and at the baseline, at level of 1, we have natural uranium. So here you see that at first the spent nuclear fuel will be very highly active. And then you see that quite relatively quickly, the activity goes down. Because when you have something that's highly active, it means that it will send out lots of radiation, there will be lots of decays, and quite soon you will have all the elements we have turned into other radioactive elements. And then after about 1,000 years, which is the blue vertical line there, you have material that is very comparable in its radioactivity to natural uranium. Now, at that point, for it to cause considerable harm to us, we would actually have to ingest it directly. And this, the same level of activity we see in natural uranium, which is sprinkled around the bedrock all over the world. There are hotspots and there are spots with less. It's also present in seawater, leaching out all the time, renewed from the bedrock. But we don't really fear this natural uranium, because it's natural. The difference in radiation is not the question here. At that point, at hundreds of thousands of years, which we consider nuclear waste to be so incredibly dangerous, it's not dangerous because it's like natural uranium, it's dangerous because of the step that we see that it went through power plants, it became artificial. So it's a perception. It's not actually as dangerous as we perceive it to be. And this kind of practical considerations for how it could actually cause us harm, you don't actually see detailed suggestions. People who talk about nuclear waste being too dangerous for us to consider nuclear, they don't have to tell or lay forward or make reports about practically how this harm would be conveyed to us. It's enough to insinuate that since it stays radioactive for a long time, the harm could surely somehow be conveyed. And this is a little bit similar, as many of us know from fear of chemicals. We know that if you tell a person that there are synthetic chemicals that in some dose can cause harm, and if they hear that it can be detected, it's very difficult to remove that feeling of fear and risk in normal people's minds when they hear this. You have to actually do lots of after processing to think that no, we need a dose that will make it a poison. And this is exactly the same situation for radiation. Yes, it will remain radioactive for hundreds of thousands of years, and we can detect that, we can measure it directly. But that alone is not enough to cause harm. We actually have to have a considerable dose somehow delivered to people for it to harm us. So, the lack of suggestions as how this harm would come is striking if you actually look. Many people don't look because it's enough to just assume. But in Finland, in my home country, you actually have a geological repository for long-term storage of nuclear waste. And they have done externally reviewed studies, the best kind of studies there are, about what will happen with waste storage, what kind of worst-case scenarios we can conceive. And what they have found is that if we assume that there would be something fundamentally wrong with the casks that contain the waste, again, this is not seem likely, but if we assume that, and if we assume that nuclear waste begins to leak, we assume that people have forgotten everything about the waste storage site, there's no caution about it, no monitoring of any kind. We have people living on top, we have them drinking the groundwater which is flushed from the bedrock, and farming food on the spot. The worst possible exposure that they can calculate for those people would be on the magnitude of eating 2 extra bananas per year. So this is why I sometimes say that nuclear waste discussion is quite literally bananas. Because bananas are radioactive, very slightly. They have radioactive potassium in them, but you get a small extra dose from eating a banana. It's not dangerous, don't stop eating bananas. So, there's a lot of fear, but when we try to look at it realistically, we find that that kind of harm is very difficult to come by. So, we as skeptics, what I'd love skeptics to help people with is risk perception and considering the risk landscape. Because another thing we learn from risk researchers is that people completely tend to forget to weigh the risks of the alternatives. not only that there is an important risk-benefit ratio to be made for each separately, but that people feel somehow that if they feel that there's this large risk for nuclear, and if we just choose to avoid that, we can breathe out in relief. We have avoided risks. We have a sort of a zero-risk choice. And this is never true. There's never something that is zero risk. So we really need to make sure that people learn to look at the risk landscape. Risk is all the alternatives. So many people think that it's even petty to start comparing waste, but this is a really important thing to teach people about risk. That we have to compare and weigh. Because it's really striking when you start looking at the fact that other energy forms, those we're not supposed to compare because they're not as dangerous, can be order of magnitude larger, they cause vastly more health problems, they actually stay harmful forever, which is the case for many heavy metals. They will, for the end of the universe, they will potentially stay exactly as harmful. And we have many industries that don't have any responsibility for taking care of the waste. They will end up in landfills somewhere and leak into the ground, or go up in smoke into the sky. And in this case, coal even causes more radioactive contamination than nuclear because you concentrate radioactive trace elements in coal ash and you spread them into the environment. But this is not really this is not as scary, simply. So, it's really time to try to make these comparisons from an accurate evidence-based level. And here, it's really surprising to many, but it's worth taking this moment of changing the perspectives. What about thinking about what kind of benefits there are to nuclear waste? Because you have several. It's tiny, it's fully accounted for, very rare to find an industry that fully accounts for the whole future of its wastes. We can actually recycle or reuse nuclear waste. We have existing reactors today that are using spent nuclear fuel in your reactors and producing more low-carbon energy from that same waste and reducing it again by many times. Nuclear waste is also solid and easy to store. And as I said, we don't need to do anything, but simply the passive passage of time will make it less harmful. Okay, so let's move on to the next point where there's lots of gaps in risk perception. So I'm talking about energy accidents, and I'd love to ask here from people in the audience, how many of you can name some of the largest nuclear energy accidents? Chernobyl? Fukushima? How many of you knew Chernobyl? Fukushima? Yeah. Next, I'd like to ask, could you name some of the deadliest accidents from other energy sources? A dam. Very good. Bayonne Dam. Right? How many of you knew about the Bangkiayo Dam? What about the Bayonne Dam? Yeah, so here is a bit like the situation with cars versus flying. We know that cars cause way more deaths, but we're not really afraid of driving. But when a plane crashes, everybody notices, and many people are really afraid. And flying is also a more unnatural form of travel, and we don't have the same kind of control over it as we do with our cars. So, the most famous nuclear energy accidents, Chernobyl, I'll just recap quickly for the context, because many people, although they can name Chernobyl, they don't necessarily know how many people were killed. So UN has had almost 10 different bodies looking into making reports on the effects of Chernobyl involving three governments, Red Cross, and lots of independent scientists, so this is quite well known. Out of the 120 emergency workers putting out the Chernobyl fires, 30 of them, about 30, died from acute radiation sickness. And then we have the immediate release of iodine in the first weeks after the accident. The surrounding population was not really even informed about the accident. They were not protected. They were not giving iodine tablets. And this led to that this iodine concentrated in the thyroids of young people, and this led to several thousand thyroid deaths in the decades that came. And thyroid can be pretty well treated, but we have had so far 15 deaths from these thyroid cancers. So these are the confirmed science-based death counts. There are estimates that with more thyroid cancers toward the end of the lifetime of this cohort, we could be looking at 160 deaths all in all. So let's say that roughly we're looking at somewhere around 200 deaths. Now, you can probably imagine that there have been energy accidents with more than 200 deaths, as we heard here earlier. So here, the first place, tragically, is for the Bangkiayo Dam. It was in 1975 in China, and 100,000 deaths is a conservative estimate of those who directly drowned. I just didn't want to make it any bigger because you couldn't see anything of the rest if I did. 250 is another estimate of people who died of the famine and epidemics that followed. It was a really horrible, tragic accident that was also kept in the dark largely for several decades. Terrible story. But we also have coal power here next in the London smog in the 50s, where suddenly you had air pollution pooling over London and thousands of people died. Even more thousands, tens of thousands got injured with asthma, other symptoms afterwards. Then you have two more dams. You have a dam in India and a dam in Italy in the 60s and 70s. And then you find two really tragic mine accidents from the earlier half of the 20th century, the Bengtsihu and Couriers in France and China. But then you come back to the more modern day. There's UFA explosion and San Juanico and Guadalajara are all gas explosions in the 80s and 90s. They all killed more people directly, several hundred people, and injured thousands. Many of these don't have injury counts. They will only give you information about deaths. But then you have the Soma mine accident, a fire in a mine in Turkey in 2014. 300 people died immediately. Now, who of you have heard of Soma mine fire? So these are accidents that are more recent and more deadly, by far, than the Chernobyl accident, and most of us are not aware of them. I didn't know more than two of them until very recently when I started looking into it. So here clearly there's a difficulty in how risk perception makes it seem so much more dangerous, because we know of one type of accidents, but don't know about any of the others. But then you'll say, what about the environmental effects? Many people fear nuclear because they think of the horrible wastelands that we live after. But Chernobyl, you can't live in a 30-kilometer area around it. So here, there's also research on what happened actually as a result of the evacuation. And you know that there are people who lived in the rural areas here in Chernobyl. And when they were evacuated to larger cities, they were actually, the result was health harm from air pollution in a larger city. They would have been better off had they been allowed to stay in their homes. There's now, as a result of them moving out, nature has taken over, and there are all more than 400 species of vertebrates living in the area, thriving populations of these. So it's clearly a very different picture from what we have absorbed culturally. I at least thought it was a barren, ghost-like wasteland. So these kind of risk perceptions really take us astray when we are looking at what kind of choices we should do with our energy policies. So Fukushima, the more recent accident, actually released so little radiation all in all, that there are no health or environmental effects expected from it. Based on the best possible science that we have, it's simply too low. But the hasty reaction to it, the fear and the evacuation already killed 1,600 or 2,000, depending on how you calculate. And the reaction in Germany alone on closing down nuclear plants has so far, between now and Fukushima, caused 4,600 deaths. There was just a paper out about this in the past month. And the rest of Europe is on track. If they will continue reducing nuclear, they're on track with increasing deaths by 100,000. Because air pollution is just so much deadlier, and there have been no good solutions to replacing nuclear with clean energy. So we need to define green goals for energy. We can't rely on risk, on this fear. We have to have these discussions about waste and accidents to try to get to a place where we can look at the evidence and see what kind of choices have what kind of effects, instead of ruling something out to begin with as too scary. So this is the situation we're in. Our carbon emissions are only rising. We need to get down quickly. If we look at expert scientific organizations like IPCC or International Energy Agency, they will actually tell you in many different ways and in very long reports and so on, that we really need every possible method at our disposal, and then some. They are relying on techniques that have not been developed yet. Carbon capture and storage on large scale in 2030, getting us to negative emissions by 2070. It's a gargantuan effort. So clearly, emissions, being low in emissions, is an important requirement for clean energy. Here you have solar, hydro, wind and nuclear being the lowest, wind and nuclear being best. But you also can't forget pollution and health. It's not very green if lots of people die. And here is the same information as in the graph I showed you before. But basically we have the safest are solar, wind, hydro and nuclear, which have very comparable health statistics. And then the third aspect is something that is overlooked way too often. And it's land use. Why? Because land use is literally a question of protecting wildlife habitats. Ask any conservation biologist. We won't have thriving ecosystems without space for them to live in. The UN Biodiversity and Ecosystems report that came out this spring highlighted the number one threat to biodiversity globally is changes in land and sea use. This is huge. If we use a lion's share of the natural habitats left, we won't have any more lions. This is really the practical issue. We can get climate change even, let's say we somehow get climate change completely under control, but we've used up all habitats. It's just a practical thing. We need to have land open. So this gets overlooked too often, and one way to look at it is power density, shown here in the table. So basically how much electricity you can produce per land area. And you can see the reason why fossil fuels have been the source of choice for all societies that they have developed, because they are such a much more easier source of power. You have denser, it's easier, quicker, cheaper to get lots of energy out of them. But clearly they have these huge other drawbacks. But nuclear power doesn't suffer from these drawbacks. And while we really need all the tools at our disposal for the carbon emission goals, we also need to be careful about being as efficient as we can with both our land use and bringing emissions down. So it's not a question of let's choose only this one which we like and then exclude the others. Because there's also a fourth aspect I'd like to add, which is the practical success, the practical results. Where can we see that we have actually made this true? Where have we decarbonized societies? And here we really have the best track record for nuclear and hydro. If you look at Europe, and the lowest emission electricity produced is in Norway, Sweden, France, Switzerland and Finland. all those countries either use significant amounts of hydro, significant amounts of nuclear, or both. So you can't ignore these huge powerhouses of low-carbon energy. And then there's the problem that we are not only looking at electricity, we actually have an even larger topic. In order to decarbonize the whole society, we also need to decarbonize heating and transport. We also need to see to it that we have access to clean drinking water in the future, and we can do that if we have plentiful clean energy by desalination. We need to help our industries, our heavy chemical industries and other industries, to become less resource intensive, to increase recycling, to free more natural habitats, less mining, less need for resources. But increased recycling also needs increased amounts of clean energy. We also want to lift people from poverty, and we want to be able to boost clean energy the most in order to get to these green goals. So, the question is really, what is the way we want to choose? So this is a graph from Stefan Quist, a Swedish nuclear engineer from the MIT who wrote a book together with Joshua Goldstein, a professor in international relations, on how some countries have solved climate change and others can follow. Basically, it shows you the data that you can find in many forms, in many places, and looking at emission reductions. Not only the Germany's path, which you can see in grey as the Energiewende, not only did it add air pollution deaths that could have been avoided, it also resulted in a situation where they haven't significantly reduced their carbon emissions. So is this something that we should take seriously? Is decarbonization a goal that is actually important to us? Do we want to protect human health? Do we want to protect wildlife habitats? Do we want to minimize land use? These are really important questions that we need to ask, and we need to try to look for the answers, looking on the evidence and not based on assumptions or risks that we imagine are there. Because we have seen countries like France and Sweden have used nuclear power to decarbonize their societies already in the 70s and 80s, and they have stayed on those low levels ever since. There are other places like Ontario and the European countries I mentioned earlier. So we should really get smart, we should listen to the scientific experts, and we should help people start evaluating these topics as a risk landscape, not as let's start by excluding something and then figure out how we can solve the rest. We need to give human health, environment, and the future of the planet the respect it deserves, and look at it from a skeptical point of view. So that's all I have to say. Thanks so much for listening.
Okay, I think that's all. Not taking practice for me, and I am sorry for a lot of my mistakes.